Imagine this. You are made of trillions of cells. Inside them, tiny machines are folding proteins every second, like microscopic origami masters, quietly building the architecture of life. Now imagine one of those folds goes wrong. Not a virus, not a bacterium, not a fungus, not even something fully alive. Just a protein. A bad fold, a biological typo, a molecule with the audacity to whisper to healthy proteins, "Be like me." And then they obey. That is not science fiction. That is prion disease. It is rare, it is horrifying, it is medically serious. And if biology ever wrote a horror story, this would be one of its darkest chapters. Because today, we're going into the rabbit hole of the disease that turned protein structure into a weapon. And yes, somewhere in this story is the deeply uncomfortable fact that your body's own building blocks can become the villain. Welcome. Act 1. The monster that isn't alive. Let's begin with a simple question. What if the most terrifying infectious agent on Earth isn't technically alive? Most things that infect us make sense to the human brain. Viruses, tiny hijackers. Bacteria, single-celled invaders. Parasites, freeloaders with ambition. But prions? Prions look at that whole lineup and say, "Cute, I'm just a badly folded protein." That's what makes them so unnerving. A prion is essentially an abnormal form of a normal protein, most famously associated with a protein found in the nervous system called the prion protein. In its healthy form, it exists quietly, minding its business like a law-abiding citizen. But when it misfolds into the wrong shape, it becomes a kind of molecular cult leader. And cult leaders don't just ruin themselves, they recruit. The misfolded protein can induce other normal versions of the same protein to also misfold. 1 becomes 2, 2 become 10, 10 become a cascade. This is the biological equivalent of one crooked brick convincing the whole wall to collapse in the same direction. Not through DNA, not through RNA, not through reproduction in the way we usually think of it, through shape. That's the horror. Because life usually stores instructions in genes. Prions store disaster in geometry. A folded shape becomes a message, and the message is spread damage. And honestly, if nature pitched this in a writer's room, somebody should have said, "This is too much, tone it down." But nature does not believe in tone. Act 2. The brain begins to unravel. Now here's where the story turns from eerie to tragic. Prion diseases attack the brain. As abnormal proteins accumulate, they damage nervous tissue. Over time, brain tissue develops the classic spongiform appearance under the microscope, tiny holes, like a structure being eaten from within. Think of a grand cathedral slowly turning into Swiss cheese. That damage can lead to severe neurological decline, severe rapidly worsening dementia, confusion, coordination problems, movement abnormalities, behavioral changes, difficulty speaking or swallowing, and eventually death. This is not a mild condition. This is one of the most devastating categories of disease in neurology. And the speed can be especially terrifying. Many neurodegenerative diseases are thieves that rob slowly. Prion diseases can be more like arsonists. A person can go from functioning to severely impaired over a shockingly short period. That speed is part of what makes disorders like Creutzfeldt-Jakob disease, CJD, so feared. CJD is the most well-known human prion disease. It is rare, but when it strikes, it is profoundly serious. And here is the psychological punch in the chest. By the time symptoms are obvious, the disease process is already deeply underway. It's like noticing smoke only after the fire has already eaten the staircase. Act 3. How can this even happen? Now your brain should be asking the correct question. How does a person even get prion disease? And the answer is, there are multiple pathways,
and each one is unsettling in its own way. 1. Sporadic. Sometimes it appears to happen seemingly out of nowhere, what medical calls sporadic. No clear exposure, no known inheritance, just a catastrophic molecular event, as if one protein in one wrong place folded the wrong way and started a chain reaction. This is the most maddening kind of horror. No villain to point at, no obvious cause to avoid, just biology going off script. 2. Genetic. Some prion diseases can be inherited through mutations in the gene associated with the prion protein. In those cases, a family may carry a biological vulnerability, like invisible loaded dice passed through generations. Imagine inheriting not a house, not a watch, not a family recipe, but a higher chance that one day, deep inside your nervous system, your own proteins may betray you. That is not just medically serious, that is emotionally brutal. And 3. Acquired. And then there are rare acquired forms through exposure to infectious prion material. These are uncommon, but they are the reason prion disease has such a terrifying place in public imagination. Because suddenly the story goes from tragic disease to, wait, can this spread? In certain contexts, yes, but not casually like a cold. Prion transmission is highly specific, rare, and medically controlled. This is not something people catch by sitting near someone, sharing a room, or breathing the same air. But historically, unusual transmission events and outbreaks, especially those tied to contaminated tissue and food chains in specific circumstances, have burned prions into public memory. Which brings us to one of the most infamous chapters. Act 4. Mad Cow and the Moment the World Got Nervous. There was a moment when the public learned a phrase that sounded like it came from a badly written tabloid headline: Mad Cow Disease. Funny name, not funny reality. Mad cow disease refers to bovine spongiform encephalopathy, BSE, a prion disease in cattle. It became globally alarming because of its link to a human prion disease variant known as variant CJD, VCJD, associated with exposure to infected cattle products in specific historical outbreaks. And this is where people realize the story is no longer just weird, it's civilization-level weird. A disease caused by misfolded proteins in animals enters the human conversation. Governments respond, food systems are scrutinized, public trust trembles. Suddenly, the dinner table becomes a place of existential philosophy. You thought you were eating a sandwich, now you're discussing protein conformation and agricultural regulation. That escalated quickly. The BSE crisis forced health systems and regulators to treat prions with the seriousness they deserve. It also taught the world a brutal lesson. Sometimes the most dangerous thing in a system is not what is alive inside it, but what is structurally wrong inside it. That lesson applies to proteins. It also applies to institutions. But that's another sermon. Act 5. Why doctors and scientists take prions so seriously. Prions are rare, yes, but rarity does not equal triviality. A falling piano is rare. You do not still volunteer to stand under one. Prion diseases matter so much because they combine 3 things medicine hates. 1. Severe outcomes. These are devastating brain diseases. The stakes are as high as they get. 2. Diagnostic complexity. They can be difficult to confirm early. They require serious neurological evaluation, imaging, specialized testing, and careful differential diagnosis. And 3. No simple cure. There is currently no routine cure that reverses the core prion process once established. Care is largely supportive, though research continues. And this is the heartbreak at the center of the story. Modern medicine can replace joints, map genes, transplant organs, deploy robots in surgery, build machines that peer into the living brain. And yet, here sits a misfolded protein, like a tiny biological mob boss, still capable of leaving medicine with painfully limited options once disease takes hold. That should humble us. It should also remind us that nature does not need to be large to be lethal. A shark is dramatic. A prion is insulting. At least a shark has the decency to look dangerous. Act 6. The dark genius of misfolding. Now let's go one layer deeper. What makes prions so uniquely haunting is not just what they do, it's what they reveal. They reveal that in biology, form is function. A protein is not merely a chemical ingredient, it is a 3D object. Its shape determines how it behaves. Fold it correctly, and it helps life. Fold it wrongly, and it may become destructive. That means the line between function and catastrophe can be absurdly thin. The difference between healthy brain protein and neurological nightmare is not necessarily a different substance.
Sometimes it is the same substance in the wrong shape. That's a profound idea. It means danger can emerge not only from foreign invasion, but from internal corruption. Not an outsider storming the gates, a trusted insider changing form. And if that sounds metaphorically rich, it's because it is. Entire civilizations collapse this way. So do character arcs, so do empires. So apparently, do proteins. This is one reason prion disease fascinates scientists and terrifies everyone else. It destroys the comforting assumption that threats must look alien. Sometimes the scariest thing is something familiar, twisted. Act 7. Fear, myth, and what you should actually take away. Whenever a topic is this scary, people drift toward myth. So let's bring the torch back to the path. Here's what matters. Prion diseases are real. They are rare. They are medically serious and often fatal. They involve misfolded proteins that can trigger other proteins to misfold. They affect the brain and nervous system in devastating ways. They are not everyday contagious in casual social contact. They are taken extremely seriously by public health and medical systems. That balance matters, because fear without clarity becomes paranoia, and paranoia is just ignorance wearing running shoes. The goal is not panic. The goal is respect for reality. Prion diseases are one of those reminders that the universe is under no obligation to design threats that fit our intuition. We expect monsters with teeth. Sometimes the monster is a protein with terrible posture. Act 8. The human meaning of this horror. Now let's step out of the lab and back into the human story. Behind every medical term is a person, a family watching someone change too quickly, a loved one trying to understand symptoms that seem unreal, doctors chasing answers while time runs out, researchers spending years studying a disease most people never hear about, because if they do not, future families pay the price. Rare diseases can be lonely diseases. They often live in the shadows because the numbers are small. But suffering does not become less tragic because it is statistically uncommon. To the person facing it, rarity is not comfort. It is isolation. And so part of telling this story well is refusing to turn it into a carnival of fear. Yes, prion disease is eerie. Yes, the biology is nightmare fuel. Yes, infectious protein sounds like the plot of a sci-fi film written by a biochemist who hasn't slept in 3 days. But it is also a real medical reality that deserves seriousness, compassion, and respect, not just fascination. Finale. The lesson hidden in the horror. So what do prion diseases teach us? They teach us that life is more fragile and more strange than our common sense admits. They teach us that structure matters, that tiny things can do enormous damage, that not every danger announces itself with noise, and that science, for all its triumphs, still stands humbled before certain mysteries.
But they also teach us something hopeful. Because every time humanity discovers something this bizarre, this terrifying, this counterintuitive, we are forced to look closer, to study harder, to think deeper, to improve medicine, to build better safeguards, to respect biology instead of assuming we have already mastered it. And maybe that is the deeper pattern of history. The universe reveals one of its horrors and then dares us to understand it. Prion disease is real. It is rare. It is devastating. And it is one of the clearest reminders that nature does not need an army to wage war. Sometimes, all it needs is one bad fold. If this video changed the way you think about disease, the brain, or biology itself, subscribe, because this channel goes deep, but we always leave a trail back out. And if you want another episode on the strangest medical realities science has uncovered, drop it in the comments, because the deeper you look into reality, the weirder reality looks back.